Good morning, everyone. This is Mr. Kim, and I'll be teaching you guys for the quadratic modeling and regression problems today. Now, remember, this is a test review, and like we mentioned yesterday, I'm going to give you a short assignment based on the quadratic modeling question and quadratic regression question, and feel free to just rewind back at any point when you're having trouble with any particular, things that I do on this video. Okay, so let's get started. This is a quadratic modeling question that I would like for us to try first. A small independent motion picture company determines the profit P for producing n NVD copies of a recent release is given to us as this quadratic equation. Now, we want to look for the maximize of the profit. Well, that's actually part B, and how many DVDs that you need to sell in order to achieve that goal. All right, so again, what is this really asking you to solve for? Maximizing the profit. It's literally just asking you to find the vertex. Okay, and this is also the vertex, but the key is that the one is asking for DVDs and the other one is asking for the actual profit and how much that's actually going to be. So what we need to do is we need to look for the x and y coordinates of the vertex. And how do I know that? Well, it's because the n NVD, the n value represents x, and this is talking about how many DVDs that company should sell, and profit is obviously given to us p, which is given like in the equation, that's your function f of x or your y. So now we have determined what variables that we're looking for. Okay, so let's take a look at this equation and see what we can do. So we have the quadratic equation, and we are looking for the vertex. In a standard form, what's the first thing we need to do? We got to look for the axis of symmetry, always, and it's going to work fabulously. Negative 3.4 over 2 times negative 0.2. For those of you who do not know the formula, it's negative b over 2a. So then, all I'm going to do is negative 3.4 divided by negative 2 times, negative 0.02 times 2, which is negative 0.04, and I believe we get 85. So the x-coordinate here will be 85 because that's your axis of symmetry. Now the y-coordinate of this vertex would be to just simply plug it back in. For the test, if you forget how to find the vertex out of a standard form, that's not good. If it's one thing that I want you to take away from this chapter is quadratic formula, factoring, and those kind of things, but also looking for the vertex is the key. So I'm going to plug it back into the equation here, 85 squared plus 3.4 times 85 minus 16. And once I do my math here, 85 squared times negative 0.2 plus 3.4 times 85 minus 16. Okay, so now what I get here is my final answer as 128.5. So this means I need to sell 85,000 of copies because that's what it's saying. N is in thousands of units. 1,000 copies of CDs. And to plug it back in, this is going to be dollars, but it's in thousands of dollars. All right, last question is to rewrite the equation in vertex form. In a quadratic modeling question, please expect that there could be questions like this, where I could ask you for the vertex, but there also could be questions where I ask you to rewrite it in a vertex format. Now, do I have to do any work for this? Absolutely not. But remember, completing the square will get you the answer as well. I need you to be able to make that connection there. But the easy way out of this is that the vertex form is always given to us as y is equal to a times x minus h squared plus k. So all I gotta do is just plug in the h, plug in the k, and where is the a value at? It's right here. Negative 0.02 x minus 85 squared plus 120.5, therefore, should be the correct answer once you put the standard form into the vertex form. Now, if you go to Desmos, and if you were to type this in literally, from the first equation to the second equation, you will get that those two would be the exact same thing. So you know you did it correctly. Okay, so now it's time for you to try the question. Please pause the video now and try this question on your own. And some of the questions here, like for example, part B is a little bit tricky. And what is the maximum height? I believe everyone knows how to do that. When will the balloon burst as it hits the ground? These are the new types of questions, but give it a try first, and then we'll go over the answer. So pause the video now and play it again once you have all the answers ready. Okay, so how high is the balloon after 1 second? Now, I believe everybody should be able to get that. That's simply just plug in t value as 1. That's all you have to do. So h is equal to negative 4.91 squared plus 27 times 1 plus 24. Literally, I'm just adding up all the coefficients, right? No big deal. Just add them up, and I get 24.5. So I get 24.5 meters as my final answer for part A. For how long is the balloon more than 30 meters high? Well, now that's the question where you have to say negative 4.9 t squared plus 27t plus 24 is going to be equal to 30. Now, you might say that it's going to be like greater than 30, but graphically speaking, what's happening is if you have a parabola shaped like this, and this is at 30 feet, you're looking for those two intersection points, and you're looking for the duration of that time. Okay? It's kind of like the same question where I'm asking for D. When will the balloon burst as it hits the ground? So how long is the balloon up in the air? It's the same type of question. So in these, you have to solve the quadratic equation. Whenever you're solving for something, I want you to remember that there are 3 ways to solve quadratic equation, which are factor, quadratic formula, and complete the square. It's always one of these 3. Most likely it's going to be quadratic formula that you're going to be using for this question because look at these numbers. They're very, very ugly to deal with. So I'm going to move this 30 to the left-hand side, and I'm going to get negative 4.9 t squared plus 27t minus 27.6. This is going to be my quadratic equation that you have to set it equal to 0 in order for us to solve. Now after that, all you got to do is just plug into the quadratic formula. We get negative 27 plus and minus the square root of 27 squared minus 4 times negative 4.9 times negative 27.6 all over 2 times negative 4.9. Whew, that was a handful. But now here, let the calculator do the magic for you. So 27 squared plus, actually minus 4 times, let's say 4.9, or negative 4.9 times negative 27.6, and I get 188.04, but I need to square root that, so I get 13.7 approximately, give or take. So hopefully you all end up with the same thing, and the denominator becomes negative 9.8. Now here, what we're going to do is we're going to find out those 2 solutions. Negative 27 plus 13.71 divided by negative 9.8. One of my solution I get is 1.356. And the other answer I would get is if I were to subtract them, so that's what? Negative 27 minus 13.71. And then I'm going to divide that by negative 9.8. So you get 4.154. So those 2 solutions, the time would be at 1.356 seconds and 4.154 seconds. Obviously, to find out our answer, we just need to subtract these 2 and you get the duration of the time will be 2.798, approximately 3 seconds that this ball was above 30 meters high. What is the maximum height of the balloon? We all know what's coming up. Axis of symmetry, plug it back in to find the vertex. Negative 27 divided by negative 9.8. So we get 2.755 as the time. So therefore, we need to plug this into the equation. Now it's really close to being answer to part B. However, so we can assume that it's going to, well, actually, this is the duration, this is the actual time. So my apologies. It should be somewhere around 2.755, so maybe somewhere in between. Let's see. So negative 4.9 times, well, I'm going to store 4.9x squared plus 27x plus 2.4, and the height you get is 39.59 meters. Okay, and when will the balloon burst as it hits the ground? Well, if it hits the ground, it means that your ground level is 0, plus 27t plus 2.4. So you just have to set this equal to 0, and then you have to solve it. And then so that would be, again, using quadratic formula. So the only thing that really changes is the c value, 27 squared minus 4 times negative 4.9. I'm going to erase this. The next part is 2.4 all over 2 times negative 4.9. So you get 27 squared plus minus 4 times negative 4.9 times 2.4. So square root that answer. Okay, and then I get negative 27 plus and minus 27.85 over 2 times negative 4.9. Now obviously here, we gotta be able to use the negative numbers down here as well as negative numbers up there because we're looking for height to be positive. You are going to get two solutions, but I'm going to use only the minus sign because plus will give you a negative time, and I don't want that. So that plus 27 divided by 9.8. So I believe we get 5.59 as our final answer. So it makes sense because from the graph that we had before, we had 1.356 reach 30 meters high, and then around 2.755 we reached the maximum, and then around 4.154 we reached 30 meters, and then eventually after one more second it hits the ground but at 0. Okay, but what's really important is that you understand the question and you understand how to set it up. So for this type of question, you gotta set it equal to 0, and you need to solve by using quadratic formula and such. All right, so the last slide that I'm gonna go over today is the quadratic regression model, and I'm gonna ask you to solve this question on your own, and then this will be a question for you guys to do on the homework. So, using a graphing calculator and quadratic regression to find the model. So here I have all these values, and I'm going to put these into the graphing calculator. So let's see if I can just use. All right. So let's say that you have your graphing calculator with you here. All right. So on stat edit, I'm going to type in 15, 20, 25. 30, 35. So everything just goes by 5s. All right, and then just type in the fuel economy here. Notice how the y value starts to decrease after it reaches some sort of a maximum height around like 30-ish. All right, so now I have the list 1 and list 2 ready. Now it says that the first question is to find a quadratic model in a standard form of the data. Okay, so what we're going to do is we're going to have to find the quadratic regression model. Here's how you do it. You go to stat, go to calc. Quadratic regression is number 5, so just press 5. List 1 and list 2, and store regression equation for those of you who have the newer versions. Press variables, which is right next to clear. And then if you go to yvars, function, and if you just press y1 and then press calculate, it's going to give you your ABC values as well as the equation plugged in when you press y is equal to. Okay, and then if you press graph, you have this really weird looking graph here, but look at the data set. You're looking for the x values to be anywhere from 15 to 70. And you're also looking for the y values to be anywhere between around 20 to 30-ish. So let me change the window setting just to accommodate for that. Let's say the x min is 0 and x max to be around, because it was 70, let's make it 80. Just to give yourself a little bit of a room of space. And the y scale to be 1. Y min here, let's make this to be 0. Actually, making it 0 is fine. Y max to be 35, and now let's press graph. There we go. Okay, so now we have all the values from 0 to 35 for y and 0 to 80 for my x. All right, so now that's the equation. You would write down your ABC values, find the speed that maximizes the fuel economy. So if I'm looking for the fuel economy that's going to be maximized, I'm going to be called to second trace. So if I go to second and then press trace, I'm going to go to calc, go to maximum. I know that somewhere around here, if I move the cursor, somewhere around here will be maximum. So I'm just going to go to the left-hand side, which I clearly know is at the vertex. And then I'm just going to go slightly towards the right-hand side when I start to fall down. Maybe somewhere here is good. So I find my maximum to be around 45.498769 and 30.44. Okay, so if I'm going to go back to my question, it says find the speed that maximizes the fuel economy. I'm going to write 45.5. So this is what I mean. And find the quadratic model in standard form of the data. That is the equation that I would use for my ABC values. I would write y is equal to, if I just go back here, of course I will not be writing all these data points, but let's say that, I think this would be a lot better. So negative 0.008, that's good enough. So going back here, negative 0.008x squared plus 0.745x, and then plus 13 point, I believe it was like 8 something-ish, but you get the idea. So you get the equation, you get the speed that maximizes the fuel economy. Now make a prediction about how much fuel you would use if you're going at 42 miles per hour, okay? No big deal. Go back to my calculator. Now you want to set the y value to be, going back to the question here, we're going to 42 miles per hour. So that means the x value is somewhere on 42 and we want to make a prediction out of it. Okay, so how do we do that? Well, you have the equation, right? And all you got to do is just go here to the graph, and you just want to press second trace, and you want to go to your value. Now the value, it asks you for x, okay, because we want to look for when x is 42, what's the approximate y value? And there we go. It's around 30.49. We get that the y value as 30.49. And that's it. So again, the most important part is that you understand the window setting of this question, how to change it to see the vertex, and utilize the second trace to your advantage to be able to find out the vertex, to find out these value points. So the answer here will be 30.4. Okay. All right. So please take a look at this question. Well, I'm going to give you this as a classwork to do, and I'm just going to give you the answers towards the end. Besides that, I think that's it. And good luck with your test tomorrow. Oh, by the way, for the test, I'll also make this as an announcement. I'm not going to give you the online portion, but I will just give you the handwritten portion, but there will be multiple versions. The whole reason why I decided to do this was because, well, first of all, I wanted you guys to have the both online and the open-ended portions, but for me, I always give out the open-ended portions, and that's it, if we were in school. Since we are hybrid, I decided to make more work for myself and give both. But since we're all virtual, I decided to just make it a lot easier for you guys and just have one day of testing where everyone's just taking the open-ended portion of the test. No multiple choice questions. So that's going to be it. Okay, all right, and thanks everybody, and I'll see you guys tomorrow.